Hello everyone, welcome back to Intrinsic Intelligence YouTube channel. Today we are going to discuss on atomic operations in Java, which comes under concurrency package. So writing a thread safe code without losing updates or sanity checks. In a thread safe environment, there are operations which are need to be secured and executed in a proper way. So atomic operations in Java ensures thread operations get right, etc. So it comes under util.concurrency package. So let's move on. What is atomic operation? So atomic operation is a single indivisible step. So for example, there are three steps: read, modify, write. So there is a count variable. It reads the current state, modifies it. It increments by +1 and then writes it and writes the incremented value. It's a three-step process. So in between read, modify, and write, if a single thread, when it executes, there is a possibility that other thread can jump in and modify the values in any of the steps, read, write, or modify the code. So what happens when we do count plus plus, it gets the temporary variable and then it reads, and the temporary variable it gets modified, incremented by 1, and the modified value. So it is a three-step process. So what happens in an unsynchronized collide? So what happens is, suppose consider these two threads. First, these two threads concurrently read the count as 0, and and at the same time parallelly it updates to +1. Now two threads incremented +1, but what should have happened is thread 1 should have incremented by +1 and thread 2 should have incremented by +2. So the thread 2 should have incremented by +2 and both writes a value 1. So this is a lost operation. So it is not properly incremented and the intended operation will fail. So it is non-deterministic, and when we try to debug this one, okay, in a threaded environment, each time you write without doing this atomic operations and cautiously, each time you run a program, you will get different set of results. Consider there are 10 threads accessing read, update, and write. So each time you run, it will be different operations will be happening. So it is hard to debug also. So atomic classes or lock-free execution. Simple. The one plain and simple solution is we can put synchronized block or put synchronized on the method, but it is very heavy. For a single operation, we are putting the entire block of code as synchronized is not recommended. So atomic operation, one such example is atomic integer. Atomic integer, you make, instead of making an int count, we make atomic integer count. And then we put count dot increment and get. So both operations happens at a time. So how it works as a, so what happens is that like a compare and swap mechanism in atomic integers. So what happens is if the current value is equal to the expected value, so then do current value equal to the new value. It won't have the same value again. So it will solve using compare and swap mechanism, and there is no lock in atomic clauses. So this is a comparison between having a synchronized atomic clause and a volatile. So atomicity. So volatile provides us no atomicity, but it provides us the value visible to all threads using the memory. So it doesn't provide atomicity. And synchronized, yes, it provides, and atomic classes also provides, but synchronized is heavy. And the mechanism is synchronized works with the intrinsic lock, whereas atomic clauses uses compare and swap. Volatile, as it makes the variable available its value to all threads, so it is mostly on the memory side. Block on threads, yes, in synchronized each thread waits to complete the task, but in atomic classes there is no such activity, and there is no concept of block threads in volatile. Performance wise, of course, synchronized is slower, atomicity scales well, volatile is fast but not recommended. Best for asynchronized is if the method or a block contains so many operations needed atomic variable, we can put multi-variable. In the case, we can put a method itself as synchronized. So atomic classes refers to the single data types and flags. Yes. So this is on the comparison. So good fit. What happens when to go for atomic classes? So when we need a single variable state, and if we have high read, low write state, and then contention, like we discussed before, it is compare and swap mechanism. So where this atomicity still can fail. So when we use volatile uh, and before a count variable, and to do count plus plus, then it is safer to go for atomic integer. So when this one still slips, okay. So when we use multiple atomic in a one transaction, like two atomic integers, and then so if we are using so many compare and swap, so it is like minimal operations it will work. Too many operations on a single thing, like updating two or three atomic integers at the same time, whereas there is together it is not atomic. So meaning like when there are more atomic operations at once go, then we should not use it. And this example on the safe fix is like instead of using volatile and incrementic, atomic integer is still safer than volatile. So like we discussed before, we should not use synchronized by default as it is heavy. So we need to cautious like when to use synchronized, and then try approaching atomic integers first. Thank you for watching this video on atomic operations, and we will meet up in one such video. Thank you and have a very good day.